I'm Steve Dowdell. I'm the Mission System Director for the Aircraft Carrier Alliance. I'm responsible for producing the mission system that will go in the two new aircraft carriers that are being designed and manufactured for the Royal Navy. On the 1st of July last year, which is 2008, the manufacturing contract was placed for the development and manufacture of two brand new Queen Elizabeth class aircraft carriers. These are two very large ships for the Royal Navy. They're 65,000 tonne ships, which makes them roughly 3 times the size of the current CVS's, HMS Illustrious, that are currently in service with the Navy today. So, whilst the manufacturing contract was placed in July 2009, design work on the carriers actually started back in March 2003, and a series of design development and concept and feasibility proving contracts have led to the contract that was placed last year, which means that whilst the contract appears to be only a year old, the design is in fact 6 years old and a very mature piece of design at that. So not only is the design mature, we're actually currently in the phase of production as well for the ship. So in terms of shipyards in the UK today, the very front part of the ship, the bow and the bulbous bow that sits under the water, is currently being manufactured in the Babcock Yard in Appledore in Devon. The back end of the ship is under manufacture at the BAE Systems Surface Ships division up in Govan in Glasgow, and recently in November 2010, as we speak, the contract for some of the centre blocks and upper blocks have been placed with A&P Tyne up in the northeast of England. The other blocks of the ship will be built in Portsmouth at the former VT yards, which are now part of BAE Systems Surface Ships division. So it really is a national enterprise in terms of building the ships. Now, these ships are much bigger than the current generation warships, and the reason for that is they're going to carry a 5th generation aircraft, the Future Combat Aircraft, or the Lightning II, as it's been badged in the UK. This aircraft is currently under development by Team Lockheed in the United States, and the UK is a key partner in that aircraft production. And indeed, we make key parts and key components for the aircraft up at Salisbury in the UK that will go into all the aircraft that are being built for all the customers around the world. Now, the Joint Combat Aircraft is very different from the Harriers, the Sea Harriers formerly, and the GR9 Harriers that operate today on the CVS's. Today, when the Navy goes to sea with the Harriers embarked, those aircraft have, up until recently, been deployed for the protection of the Surface Action Group. So where we have a number of ships at sea with a CVS, the aircraft are there effectively to perform combat air patrol and to be part of the defensive assets of that task group that's gone to sea. In the future, and utilising the GR9s today, we're working up what it means to deliver what's called carrier strike. So that means that the aircraft carriers of the future, carrying the JCA, will be asked to go out and potentially carry out missions several hundred miles away from the task group at sea. That means that we need to have an awful lot more intelligence about what's happening both around the ship and in the intervening distances, which may be 200 or 300 miles away from the ship, where the aircraft will be doing their business, if you like. So quite a different role, and that's carrier strike as opposed to combat air patrol. So a big change in the role of the ship. It's a much bigger ship to accommodate those aircraft, and we can accommodate up to 40 aircraft today, which is a far larger number than we can accommodate on the CVS's. What we've seen in the videos around the visualisation and experimentation events is some early systems proving. By that, we have to take into account that coming onto the new aircraft carriers, we'll have around 59 or 60 systems being deployed. A system might be a radar, it might be an air traffic control camera, a glide path camera, it might be a management system, it might even be a meteorological system to give us the weather forecast around the own ship, it might be an internal electronic network device or a piece of blown fibre cable which we use to transport the electronic data signals around the ship. So the mission system is around 59 or 60 subsystems which are all brought together. That's quite a complex undertaking, and as we described earlier, the role of the ship from the current CVSs to the future aircraft carriers is quite a different role. So what we're trying to do through the visualisation and experimentation work is to ensure that as we work collaboratively with the end user, with the naval operators and the various stakeholders, that we really are moving forward and maturing the design of the mission system in a way that will fulfil the needs of the end user and those operators. So to that extent, what we do is we build some early representations of the mission system. We might have a system off the shelf that's going to go into the Queen Elizabeth class. We might have an early or a prototype development system. Or we may have a system we're thinking about procuring. And we can get some of those systems together early on in the life cycle, as we sit here today, 6 or 7 years before we deliver the end system, and start to work them together to start to tease out some of the integration problems that we may have downstream, but also to inform the end user of the behaviour of those systems, so he can check out that the performance of the systems, the functions they deploy at sea, are going to do the job that he needs to do to support his carrier strike operations and indeed all the other operations that the carriers will be asked to undertake. So we take those early representations, we take those prototype systems, we put some glue, what we call glueware around them so they can talk to each other. We bring in real operators. So it's important to us that we meld together an environment where we have development engineers, integration engineers and real operational users to get together to integrate the user into the system as well as to integrate the systems together. So we see system integration as engaging the user, integrating the user, as well as integrating the computer-based systems in the electronic systems that are at his disposal on the ship to do his job. And that's the central tenet here. We call it visualization experimentation because rather than kind of overload those end users or the operators with lots of paper specifications, nobody wants to read a tech manual for a piece of software or a game. They want to play it. And if you like, we've moved that paradigm into the engineering environment. We stick the operator in front of the software. We get him to use it and to play with it in the ways he will use it on the new carriers. That means he can test it out. He can see if it's fit for purpose. Is it going to do what he needs? Is it going to do what he needs when he puts it up with the system next door to it? Is it going to do what he needs when he puts it up with the operator he sat next to in the way we've chosen to configure the operational space of the ship? Those are the things we're trying to tease out well in advance of freezing down the implementation detail of those systems and the compartments in which they'll be operated in. So, while we talked in general about bringing together prototype systems, early representations, a very good example, which you may have seen going on in the background in some of the videos, is that we've brought over from the United States some of the software that's associated with the mission planning for the aircraft. So whilst the Joint Combat Aircraft today is in prototype form and is being tested, what we've been able to bring to the UK from Team Lockheed through the Joint Programme Office is some real software that will sit and perform mission planning both on the aircraft and in terms of supporting the aircraft as you plan the mission before the pilot goes on board with his pre-planned mission. So we brought that software to the UK. We've brought it together with some of the mission system software that sits on board the Queen Elizabeth carriers, and we put the two systems together. We put them together with the operators that will end up using them, and that way we can start to really tease out some of the information management issues that we will have with a fifth generation aircraft that brings back from the battlefield an awful lot of data about what it's seen, some intelligence and reconnaissance data, and also a lot of logistics data about the performance of the aircraft. So we're really looking at investigating how we prepare the mission for the aircraft, how we brief the crew before he takes off and does his mission, how we debrief him both in the air on the way back with his prognostic health monitoring information, and also when we get a big load of terabytes of data coming off the aircraft, which we then need to analyse, both in terms of a mission context, so did the guy see some interesting intelligence on the way back, and from a logistics perspective, Is the aircraft reporting that it needs some maintenance activities before we turn it around quickly and deploy it again on another mission? So this is really, if you like, part of a global enterprise to start integrating the aircraft and the aircraft carrier well in advance of seeing either of those platforms in the real world.